Good morning, pilot teachers and students. Good morning, class. All right, thank you very much. You may sit down. Okay, our topic for today is simply looking at a nuclear reactor. Now, in our last lessons, we saw the fission process, and that fission process is quite a complex process, and it is always, or it must always happen in a nuclear reactor. Now, basically, before we go on to looking at this nuclear reactor, what is a nuclear reactor? Can somebody give us an explanation of a nuclear reactor? Mary, what is your explanation of a nuclear reactor? Okay. Okay, Mary has no idea. Jolene.
Nuclear reactor is part of a power station which produces steam from turbines.
Okay, it is a part of a power station or nuclear power plant where fission takes place. Okay, we can simply define or explain this nuclear reactor as a device in which a control chain reaction takes place. Right? Remember when we studied fission, fission is a process where chain reaction has to take place. Right? Meaning that an atom must split up to form two, and then it emits neutrons at the same time. And then you find that these neutrons are being absorbed by other surrounding atoms, and then it goes on. And you have what is known as a chain reaction. So that is basically the definition of a nuclear reactor. All right, you can have definition, or you can write down the definition, and then after looking at the definition, we'll go on to looking at parts and functions of each one of those nuclear reactor. Now, also, if you have your textbook, that is Physics Matters, you can turn to page 270. That is for the moral students. Okay, pilot students, if you have something, physics, okay, you can use one of these books to find out more information on nuclear reactor, and that is basically the Physics Matters, okay, written by Nick England. All right, just have the definition of that. I will now move on to okay, the process of nuclear fission is all happening in a nuclear reactor. Okay, we do not have a reactor which will produce power through fusion, but it is believed that in the future, when there is increased technology and ideas, probably people may build, or scientists may build reactors which will be going through the fusion process to produce energy. Okay, the nuclear power station is okay. That is especially in this nuclear or fission process will be taking place, and you also, or you probably have known from other or past lessons, when fission is taking place, right? Let's say for this, right? If it is 235, it will have to absorb a neutron. and then that becomes, okay, y2 36. Okay, but this one stays the same, and then it emits. Okay, this will further break down to form other two. Okay, another will be half of that, which is, let's say if this is 57, this one will be 53, or let's say 38 plus, all right, one of these. Okay, what is 57 plus, or let's say 256 minus 57 would be, 236 minus 57 would be? One, 137. Okay, 179. All right, probably in here we can have 177, and then plus two neutrons. Okay, and you also have what is known as this energy being released, and the energy is sometimes given in, okay, 1, or it is simply as, okay, what does this stand for? Maima, can you?
Mega electronic volts.
Okay, good. This MEV stands for mega electron volt. Right, simply you also see that, but 1 M EV is equal to 1.6 times 10 to the minus 19 joule. Okay, that is the same. So this amount of energy is given from this fission process. Okay, we will move on to all right. Once this heat energy is given off, you'll find that the steam is used to turn a turbine, which will control, or which is connected to a generator, and this generator will turn to produce electricity. And if you know, a generator is a device which will convert either it is heat energy or something like movement energy into electricity. Okay, in a generator you have basically the dynamo, and this dynamo will turn to produce electricity. All right, we shall move on to Okay. All right, the first part of a nuclear reactor is the fuel rods. And as you all are aware that the fuel rod must always be something or some element which can go through fission process. An example given there is uranium. Right, this nuclear reactor, but I will go through only for the main parts, which are the moderator, the control rods, and the fuel rods. Okay, those are the three main parts that I will discuss. But if you have to look at a picture of a nuclear reactor, there are many, many parts to it. Right, moving on to the second. Okay, this moderator must be simply made of graphite, and it is a carbon. So you find that the fuel rods are embedded in the moderator, which is a graphite. And the purpose of that moderator is to slow down neutrons which are produced in fission. If you can remember the fast neutrons, when they are going past with great velocity, it is a moderator that will stop this. We shall now move on to the last part in the function. Okay, basically the boron control rods will have to regulate the production of energy in the nuclear reactor. Right. If you want to stop the production to go on, then you can either post-set control rods right into the center of the reactor. Okay, that will stop the amount of energy that is produced. Okay, that is the third most important part of that nuclear reactor. I will show you the diagram or the picture of exactly how it happens in the nuclear reactor. I will do my explanation. For the more students, probably your teacher will have to find a picture or diagram of a nuclear reactor and then explain to you later on. Okay, finally, to our diagram of a nuclear reactor. Some of you have your pictures there which you can follow. Okay, for pilot students, if you can look up, I'll do my explanation. All right, basically those, because the space is quite small, I have to put numbers in here to just indicate. I will give you the words of the names of each one of these beside each of these numbers. Right, the first one is where the cold water will be flowing in, and it goes out that way. And in here you have a pump which will have to pump this air into here. Now basically that is the carbon dioxide that is flowing in here. All right, the purpose of that carbon dioxide is to, what is the purpose of that carbon dioxide? Veronica. Okay, what do you think is the purpose of that carbon dioxide in here? Okay, remember when you were looking at the cloud chamber, what is the purpose of that dry carbon dioxide? Okay, it is to cool. Okay, it is somewhat placed in here so that whenever there is extreme energy produced in here, the carbon dioxide will have to cool this area. All right, looking at number 6, that is basically the the rods, which are uranium rods placed in here. And the number 7 is simply the, what do you think number 7 is? It is the graphite moderator. That is basically to slow down the, okay, it controls or slows down the neutrons. And in here you have the, okay, the boron rods which are responsible for slowing down the reaction. And then number 9 will be, what is number 9? Okay, it is a hot gas that is moving out from this. And sometimes you'll find that the carbon dioxide is used to remove the heat in here, and then it brings it to the turbine. Okay, the water cooler in here or the heat exchanger in here will have to change that, and then it is used to steam, okay, steam water, and then that steam is used to, okay, turn the turbines, which are then used to drive the generators, and then you have the generators which will produce electricity. So it is quite a complicated process. The number 4 one is simply the, okay, shielding that is placed in here. Okay, that is basically the concrete. Why? Because when you have this process going on, radiation will be moving out, so the purpose of this concrete is to act as a shield. All right, that is basically the diagram of a nuclear reactor, right? Energy being removed and then it is placed in a boiler which makes or turns that water into steam, and then again the steam is taken to a this turbine will have to produce or turn the generator, and then generators are used to produce electricity. So it's quite a complicated process, but following that simple diagram, it can give you an idea on how nuclear reactors work. Okay, those are the list of names beside each one of those. Okay, so I've said you have your diagrams. For the model students, you have your diagrams, but for pilot students, if you still want to take down the notes on this diagram, okay, probably your teacher will have to provide you with a diagram of a nuclear reactor, and then further explanation can be done on that. Right, we'll move on to activity questions. You can answer the questions. There are only 2 questions. Part 2 has 6 parts to it. Okay, question number 2 has 6. All right. In probably tomorrow's lesson, I will give you an activity on half-life. Basically, how we can do that is we'll put some coins into a box or something like that, and then you will time, meaning that you will have to time that, and then you shake the box, and then you find the number of heads that are turning, and you collect them, and then you record. So after this, I will be asking you to plot a graph and then showing you until you remove every one of those coins in the box. Okay, that is just a simple demonstration to show half-life. So model teacher will be showing you that. And for pilot teacher, if you want to still show this concept of half-life, you can use coins. Simply put that coin into a box, and then you time. Probably 2 seconds or 5 seconds, and then you ask the students to shake the box, and then you find the number of coins that will turn. Okay, if you find the number of heads that turn and then facing, then probably you pick out those, and then you record against the time, and then so on until you remove every one of those coins in the box. Okay, that is just a simple demonstration to show half-life. Okay, moving on to question 2. Just write the answers down. What is the purpose of the concrete shield surrounding the nuclear reactor? And question 2B will be, why is the carbon dioxide gas pumped into a reactor? Okay, just answer the questions. I will move on to question C and D. Okay, you don't need to copy those. Just answer the question. C would be what is the isotope of uranium? Or what isotope of uranium produces energy in the few rods? And D will be, will the few rods last forever? Okay, you have to explain that. Okay, just stand up. You start from question number 1, write down. So 1, 2, 3, 4. 1, 2A, 2B, 2C, D. What isotope of uranium produces energy in the few rods? And D, will the few rods last forever? Okay, you have to explain that. Okay, move on to the last two questions. That is C and F. Okay, what is the purpose of that graphite moderator? And F will be, what would you do if the reactor core suddenly got too hot? Right, if you decide to have one in a country and you're one of those people who are manning that place, and if the reactor was too hot, what would you do? Question 1, 2A, 2B, 2C. All right, first question, let's have the okay, by now each one of you would have known the answer to each one of those questions. Okay, we'll go by this way. Okay, I will ask the first person to stand up and then answer each one of those questions. If he is correct, then he will have to sit down, and then if it's not correct, we'll move on to the next and then the next. All right, so the first person up front is John. Right, I will now ask John to stand up and probably answer question number 1.
Chain reaction is when an atom goes through a fission process, and then it splits up, and then there are two fast neutrons that are given off. They also strike other uranium atoms close by, and they also split. So that's how a chain reaction works. And in a nuclear bomb, it's not controlled. So like the electrons they split, and then the atom multiplies, and it's not controlled. So it's out of hand. But in the nuclear power station, that's where it's controlled. So controlled by the carbon dioxide gas to cool the reactor.
Okay, Mark, do you think that explanation was yes or no? Okay, good. He is quite correct, and the explanation was done well. Okay, looking at this in a chain reaction, you have a fission process where an atom has split up, giving off 2 and then or more neutrons, and these neutrons are absorbed by other atoms, and then it goes on. And looking at how it works in an atomic bomb, basically when it explodes, it's outside the atmosphere, meaning that it is not controlled, and the chain reaction can go on in an open air. But if you actually look at a nuclear reactor, it happens in a controlled system, meaning that there is a shielding it from a radiation to the surroundings. So that is why, or that is the difference between reaction, or let's say fission reaction, happening in a nuclear bomb and also nuclear reactor. Good. We'll move on to question number 2A.
Question 2A, it says, what is the purpose of the concrete shield surrounding the reactor? The purpose of the concrete shield is to absorb neutrons and other radiations.
Okay, very good. The purpose of that concrete shield is to absorb neutrons and the radiations. Okay, moving on to question 2B.
Carbon dioxide gas is pumped around the reactor to keep it cool by carrying the heat away from the reactor.
Okay, very good. Basically, there are two things that happens. One is to cool that reaction, and in that process, it also carries the heat from that reactor core and then out into the heat exchanger. Okay, very good. Okay, moving on to question C.
The isotope of uranium that produces energy through that is used in the fuel rods is uranium-235.
Okay, uranium-235 is the one that is used. Uranium-238 is a common one that is happening, but this uranium-235 is the one that is more radioactive. All right, D.
The answer is no, because all the radioactivity is half-life.
Okay. The answer is no, it will not last forever, especially in a nuclear power plant when all the energy or reaction is finished, because it will have to break down. So once all the energy has been used up because of the mass, in our last lesson you know that a mass is a concentrated form of energy. So once each one of these is used up, then this will be useless. All right. Moving on to E and F. this person. All right, quickly. What is the purpose of that profile moderator? What have you got here? Slows down the vision. Okay, you get ready for F, and then the last person, you give us a summary of what you went through. Are you going to give us any? Okay, quickly.
The purpose of the graphite moderator is to slow down the movement of the neutrons.
Okay, basically to slow down the movement of the neutrons. Because when they are fast, in other words, the moderator there will be slowing down so that they are directed towards the atom or the nuclear event atom. All right, Ruli, you tell us, if you were one of those person in that place looking after the nuclear reactor, what would you do if it becomes too hot?
Because boron absorbs neutrons very well, I would have the boron rods pushed right into the core of the reactor to stop the chain reaction completely.
Okay, very good. You will have to use the boron control rods that is to be placed right into the reactor core, and that will help to stop down the reaction. All right, we'll just have a summary of what you went through, and that Waki, you can explain, or you can stand up and then just give us basic conclusion.
To summarize, nuclear reactor is a device in which controlled chain reaction takes place, in which in a nuclear power station, fission in a nuclear reactor provides energy. This is carried by carbon dioxide gas, which is pumped around the water to turn water into steam. In a controlled chain reaction, which is in most power stations, in an average, only one neutron from each fusion will strike another nucleus and cause it to divide. But in an uncontrolled chain reaction, the neutrons from each fusion strikes other nucleus. This is how nuclear bombs are made. It is a frightening thought that a piece of a pure uranium-235, the size of a tennis ball, has enough stored energy to flatten it down.
Okay, very good. That is our little conclusion from what we have studied or covered in the lesson. Okay, Waki has given us the conclusion. Our key phrase will be nuclear reactor. Good afternoon, pilot teachers and students. Good afternoon, class. Good afternoon. All right, thank you.